Welcome to the last lecture of Cisco NetAcad CCNA2 Switching, Routing and Wireless Essentials lecture series. After this, I will post my lecture series on CCNA3 modules. If you haven't seen my previous lectures, I will leave a link in the description for the playlist. I would also recommend that you watch the Introduction to Networks lecture series before you move forward with this course. Today, I will cover module number 16, which is Troubleshoot Static and Default Routes. The primary objective of this module is to learn how we can troubleshoot static and default route configurations. We will cover packet processing with static routes and troubleshoot IPv4 static and default route configuration. Packet processing with static routes. Static routes and packet forwarding. In this diagram on the right hand side, the PC1 addresses a packet to PC3 and send it to the default gateway address. So the PC1 is addressing a packet to the PC3. So it's trying to reach the PC3 across this network, just like this. And it is now addressed to the default gateway. So the default gateway is right here on the R1 side, G00, whatever, and in here. So just G000. So when the packet arrives on the R1 G000 interface, which is the default gateway of PC1, R1 decapsulates the packet and searches the routing table for a matching destination network entry. If the destination IP address matches a static route entry, R1 will use the static route to identify the next hop IP address or exit interface. If it does not match a specific route to the destination network, then R1 will use the default static route if it is configured in there. If it does not match a route table entry, then the R1 will drop the packet and send an ICMP message back to the source, in this case the PC1. So these are the three options that could happen when this PC1 send a packet addressed to the PC3 through this network. So as we learn in the past modules, you should be familiar with what I'm talking about, because this is basically putting everything we learn in this course, together in a simple network environment. So basically we have a packet that is addressed from the PC1 to the PC3, and the PC1's default gateway is the R1's G000. So the packet first gonna reach that default gateway, then it goes through for figuring out the destination IP address in this way. So the first, if it looks for the static route entry and identify the next hop IP address or exit interface, if it matches. If it does not match, then it looks for the default static route, and if none of these actually work, the packet gonna get dropped and an ICMP message will be sent back to the PC1. So that's a fundamental concept that you should get out of this slide. Assuming the R1 matched a routing table entry, it encapsulates the packet in a new frame and forward it out the interface S010 to the R2 router. So assuming it matched something in the routing table entry that has a entry in there that matches, that shows it's supposed to go to this S010, what's going to happen, it's going to re-encapsulate it and then it's going to send it out to the R2. Remember, when the packet first arrived from the PC1 to the R1's G000, it's going to remove the encapsulation here, right? So they're going to re-encapsulate it and send it out to the correct port, in this case S010. Then the R2 receives the packet on its S010 interface. It also de-encapsulates this one and process the packet for the same way the R1 did. So it goes through the same steps as described in the previous slide. It's looking for matching of those information, either a static route or some kind of the destination entries. And it's going to look for a match. So it de-encapsulate and process the packet the same way, similar way as the R1, right? So when the R2 finds a match, just like the R1, in the routing table, it uses the identifies next hop IP address or exit interface and send the packet of its interface out the S011 towards R3. So assuming there is a match in its routing table, the R2's routing table, it either identify the next hop IP address or the exit interface, and then in this case, assuming it properly identify the S011, it's going to send towards the R3 router. So we are getting closer to the PC3 now. So the S3 now received the packet because the R1 and R2 already had done their job of matching the destination information through their routing tables, and now S3 has received the packet, but it's going to do the same thing as what the R1 and R2 did, which is de-encapsulating it, and it also going to searches the routing table for a match. And this time the destination IP address of the PC3 matches the directly connected G00 interface, because now the packet is pretty much arrive in the last kind of hop. It is the last hop, right? That's it. It's after that we have a switch and the PC is connected, PC3 is connected on the other end, right? So therefore the R3 searches the ARP table for the layer 2 MAC address of the PC3 because it is directly connected. Remember, because it's directly connected, the R3 searches the ARP table for the layer 2 MAC address of the PC3 in this case. So that didn't happen in these two routers when the PC1 sent the message, but it does happen here because it is the directly connected end device. So therefore the R3 searches the ARP table. So remember, the ARP table is a layer 2 MAC address for the PC3. If no ARP entry exists, then the R3 sends an ARP request out the G000 interface. So the PC3 responds with an ARP reply containing its MAC address. R3 encapsulates the packet in a new frame and uses the PC3's MAC address as the destination MAC address and the G000 MAC address as the source MAC address. Then the frame is forwarded out from the interface G00 and PC3 receives it and processes it accordingly. So that is a simple path across a network with 3 routers connecting these two devices. So the PC1 and PC3 are connected through 3 routers. So that is the process it has to go through. So you should be familiar with this, even if I don't go through these slides, because considering what we have learned on our previous lecture series, which is the Introduction to Networks lecture series, as well as this lecture series, you should be very familiar with how that process works. This is basically a quick brief overview of what you have already know, like what you have already learned in this class and the previous class, right? So this is just an overview of what you have learned. Again, if you haven't seen my previous lectures, please go back to my YouTube channel and watch those previous lectures so that you'll have an idea about some of the concepts that we have covered there. But if you have gone through those lectures or have taken those classes through your academic institution or from through Cisco, then you know how exactly this works. So I'm going to give you a brief summary again before we move forward, just so that you understand. So what happened here is that the PC1 wants to reach PC3. So it sends a message with the IP address of the PC3. It reaches the default gateway, and the default gateway router gonna look in its tables and look for any routing information in their routing table that would match that the request. If it finds a static route, it send that through that static route. If it finds the default static route, if it is configured, it will go send through using that. If it does not have any entries matching on their routing table, the packet will be dropped. Same thing happened in R2. It's the same process, but now it's going to get forwarded towards the R3, and in this case, because assuming there is a match. So in the previous one, we assume there is a match to R2. There are going to be a match to R3. It will be forwarded to R3. And then again, this time, it also does similar thing, but this time what's going to happen is the R3 going to search for the ARP table for the layer 2 MAC address of the PC3 because it is directly connected, and forward that information, the packet, to the PC3. So that's the simplest, easiest summary of what happened here. So the PC1 reaches the PC3 through 3 hops. So we have 3 routers, and that's how the basic process works. And you should understand that from what we have learned from our previous lectures, right? So keep that in mind. Next, we're going to look at troubleshoot IPv4 static and default route configurations. Network changes. Networks fail for a number of reasons. An interface can fail, a service provider drops a connection, links that become oversaturated with multiple connections, or bandwidth saturation. An administrator may have entered a wrong configuration, causing the networks to go down or slow down even. Network administrators are responsible for pinpointing and solving these kind of issues. And to efficiently find and solve these issues, it is advantageous to be intimately familiar with the tools to help isolate routing problems quickly. So you need to know which tools to use at what time, and more tools and how to use those tools is very important when you're trying to narrow down a problem. So here are some common troubleshooting commands. As I have mentioned multiple times, the easiest troubleshooting command on any network systems or any system that is connected to a network, any device that is connected to a network, is the ping command. It verifies the layer 3 connectivity to destination. Remember, ping uses the ICMP packets, and its extended ping provides additional options. So in Cisco, we have extended ping. It can either increase certain parameters, decrease things, or modify certain parameters. And I already have a video posted on my YouTube channel, which I have gone through these extended pings. I will put a card on the top right hand corner so that you can watch it. I will leave a link in the description as well. The other one is the trace route that verify path to destination network. It uses the ICMP echo reply messages to determine the hop to the destination. So in this case, we have the previous one, we had 3 hops. So the trace route can pinpoint those 3 hops. Show IP route, which displays the routing table, used to verify route entries for destination IP addresses. Again, I have gone through this in my previous lectures as well. Show IP interface brief. I went through the previous lecture, which displays the status of the device interfaces, used to verify the operational status of IP and IP address of an interface. Show CDP neighbors. That displays a list of directly connected Cisco devices, also used to validate layer 1 and layer 2 connectivity. So those are the very important commands that you can use for troubleshooting purposes. So ping, trace route, show IP interface brief, and show CDP neighbors. Solve a connectivity problem. So remember that network diagram that we were looking at a few slides ago. So that's the same network diagram here. So right now we have connectivity from, so it says connectivity from PC1 to PC3 fails. We don't have the connectivity from PC1 to PC3. So there is a failures along the network. Extended pings from R1, that is from the left hand side router, where's my mouse? Right here. So this one, R1, extended pings from the R1 G000 interface to PC3 fail. So it tries to ping the PC3 and it fails. The pings from R1 S010 interface to R2 are successful. So if you ping from here to here, it's fine. But if you ping all here to all the way to here, it's not. The pings from R1 to R3 are successful. So if you ping from here to here, that's okay. So for example, if you ping from G000 to S010, for example, and it's going to be fine. So the R1 can reach the R2 as well as R3. I believe this is a typo. It should say actually S011, not S00. So for example, this interface S011, that means the R1 can reach the R3 as well. R2 routing table shows the problem and the incorrect static route is removed. So if you go to R2 router and type show IP route and then you pipe or filter the gateway parts, what happens is you see that there is an incorrect static IP route and that needs to be removed. A new static route solves the problem. So the new static route would be IP route 172.16.3.0.255.255.255.0, 172.16.2.1, and that would give the new static route. Why that should be the correct one? The network associated with on this side is 172.16.2.0, not 192.168.1.1. So that means the static route is incorrect. So now we have corrected it to that 172.16.2.0, and now the proper static route is entered, and that should fix the problem. So this is a quick example, a quick demonstration of solving a connectivity problem. Unfortunately, this is pretty much the end of this lecture. It's a very quick lecture, and I honestly don't like this particular module because it's very short, first of all, and it doesn't cover much of the problem solving methodologies and techniques. That is because in our advanced class, our next few classes for CCNA that I'm going to be doing, we will go through it. If not, I will create my own lecture series and add some value to troubleshooting courses. But for now, this is the end of this lecture. So I know, but for your exams and quizzes, it's not many questions you're going to get with this because this probably going to be some of the lab questions that your instructor may ask, where they will ask you to troubleshoot using your basic logical and analytical skills. So other than that, well, this is the end of this lecture. So now we're going to learn, we're going to cover what we have learned quickly. So there's a packet tracer file called Troubleshoot Static and Default Routes. If you have access to that file through your Cisco NetAcad or through your academic institution, please go ahead and download and do them. If you do not, I will find a copy and try to post it to my YouTube channel if I find it. There's another lab called Troubleshoot Static and Default Routes. If you don't have access to it, I will try to find a copy of that lab and post to the sanuja.com website. If you do, please go ahead and do them. And finally, here's a summary of this brief, very quick module, which is honestly is not a very good module, but this is what the Cisco NetAcad program is about, and these slides are provided by Cisco themselves. So in this brief module, we learn a host sends a packet to another host and send it to the default gateway address. We learn when the packet arrives on a router interface, it de-encapsulates the packet and searches the routing table for matching destination network entry. And if the destination IP address matches a static entry, the router will use the static route to identify the next hop IP address or exit interface. We learn if it does not match a specific route to the destination network, then the router will use the default static route if it is configured. And if neither of them satisfy, the router will drop the packet, but at the same time it will send an ICMP message back to the source so that the source knows that it was unsuccessful. If the router match a routing table entry, then the router encapsulate, so re-encapsulate in this case, right, the packet and forwards it out to the appropriate interface. The packet is forwarded from router to router until it's reached the destination network. And when the packet reaches the destination network, which is the R3 in our example, the last one, that router will search the routing table for its match. When the destination IP address matches a directly connected Ethernet interface, the router searches the ARP table for layer 2 MAC address this time. Remember? Because right now it is the local one, right? So this is the local network. Router has received the local network of the local network router has received that packet, right? So now what's going to happen is it's going to search the ARP table for the layer 2 MAC address of the destination IP address in this case. And if no ARP entry exists, the router sends an ARP request out of the Ethernet interface. So in this case, it's going to look for the connected device, and then the destination host respond with an ARP reply containing its MAC address. The router then re-encapsulates the packet in a new frame. It uses the MAC address of the destination host as the frame destination MAC address and the MAC address of the router Ethernet interface as a source MAC address in the frame. The frame is then forwarded out of the appropriate interface as a result. The packet then arrives on the network interface card or NIC of the destination host and is processed accordingly. And we learn about common Cisco IOS commands for troubleshooting: ping, traceroute, show IP route, show IP interface brief, show CDP neighbor details. Remember, for IPv6, basically show IPv6 route, show IPv6 interface brief can be used on Cisco IOS. Again, this lecture is very short, and I will go through a much more comprehensive troubleshooting lecture that is not related to particular Cisco modules. That will give you a better idea of more complex troubleshooting and problem solving methodologies. If you like these type of lectures, please thumbs up this video and subscribe to my channel. If you have any questions regarding any of the topics that we have covered, you are more than welcome to reach out to me either through leaving a comment in this video or through my website. Please make sure to go over all your notes and previous modules before you take your final exams and final lab exam. Good luck and have a nice day.